Hey, Professor Erickson, this is our Lab 6 two-channel audio mixer. Here's our design for the entire circuit. We wanted to use an inverting amplifier to amplify the two audio signals that we were putting in. And then we decided to put both of the audio signals into the inverting receptor of the amplifier, and to have essentially two voltage dividers for each input. This would allow us to adjust the relative intensity of the signal from each audio source. So we found the equation for the voltage out is given here. And what this potentiometer allows us to do is to crank up the resistance here or here, resulting in a larger voltage drop, which gives you a smaller voltage in for that particular signal, effectively lowering the output of that signal. So when you're playing it through a speaker, if you turn this resistance up, there's a larger voltage drop across it, a smaller voltage in from that signal, giving you a quieter sound coming out of the speaker. And for component values, we're given the range of 0.1 to 10 of RF, which is the feedback resistor, and RX, which would be the equivalent resistant of these two, of the potentiometer and static resistor in series. And we just picked arbitrary values of 19 kiloohms for RF, and then 1.9 kiloohms for R1 and R2, allowing us, once the potentiometers were effectively at zero, shorting across them, you would get that ratio, the top end of that ratio of 10. And when you turn, and the potentiometers we picked to be very large, 232 kiloohms and 189 kiloohms, so that when you turn them all the way up and there's a full resistance across it, it would be far below 0.1. And this covered the whole voltage range. And Tom is going to show us sort of a proof of concept of this design.
Dude, is there a way to stop the video so you